Hello everybody, my name is Tom Stevens, a Year 12 student who is currently studying AS level maths. And if you love maths as much as I do, and perhaps you need a little bit of help to tidy up a few areas, then my series of tutorials might be the thing for you. I am going to be focusing on MFP1, Chapter 1, Roots of Quadratic Equations. I've picked out a typical exam style question which is most likely to come up in the exam. It gives us a quadratic equation which is alpha x squared add 5x minus 7 equals 0, and they say that has roots alpha and beta. Okay, the first part of the question asks us to work out alpha squared plus beta squared and alpha cubed plus beta cubed. Okay, now they don't seem very nice, but in order to work these out we're going to have to work out the sum of the roots. So alpha plus beta, which is a simple formula, which is minus b over a, referring back to our quadratic. So that would make the 5 negative because that's already positive. So that's minus 5 over 1, which means that the value of alpha plus beta is minus 5. And to work out alpha beta, similarly, we do c over a, which would be minus 7 over 1. So we know that the value of alpha beta is minus 7. So there is a further formula that you will have to learn for alpha squared plus beta squared, and this comes in the form alpha plus beta all squared minus 2 alpha beta. Okay, so now we can substitute these numerical values into this in order to work out the value of alpha squared plus beta squared. So we say minus 5 squared minus 2 multiplied by minus 7. So minus 5 squared is 25, minus 2 times by minus 7 is plus 14, and that gives us the value of alpha squared plus beta squared as 39. Okay? Similarly, to work out alpha cubed plus beta cubed, we have to follow a similar formula, which is simply alpha plus beta all cubed minus 3 alpha beta brackets alpha plus beta. Okay, as you can see they're all in terms of these two, alpha plus beta and alpha beta, so we can substitute numerical values in like we did for the previous one. So minus 5 cubed minus 3 multiplied by minus 7 multiplied by minus 5. Okay, so that is going to give you minus 125, which is minus 5 cubed, minus 3 times minus 7 is 21, multiplied by minus 5 is minus 105, which then gives you the value of alpha cubed plus beta cubed as minus 230. And there's the first part of the question complete. So you've worked out the value of a alpha squared plus beta squared and alpha cubed plus beta cubed. However, the next part of the question asks us to work out a quadratic equation with integer coefficients which have roots alpha squared over beta and beta squared over alpha. Now, we've worked out the original sum of the roots and the product of the roots, so we need to find out the new sum of the roots, which we would put down as alpha squared over beta add beta squared over alpha. Now that doesn't look very nice to deal with, does it? So we're going to have to rearrange these fractions so that we can get them in terms of alpha beta and alpha plus beta. So what we do is we times alpha squared over beta by alpha and beta squared over alpha by beta, so that we can get a common denominator. So that one is going to become, so I'm going to times the alpha by these, which gives us alpha cubed over alpha beta. I'm going to times the beta by beta squared over alpha, which is beta cubed over alpha beta. Now we can merge them together because they've got the same denominator. So we say that's alpha cubed plus beta cubed over alpha beta. However, hang on a minute. Look back. We've already worked out alpha cubed plus beta cubed, so we don't need to do much further working out. We know it's minus 230. So we can say that is minus 230 divided by minus 7. So the new sum of the roots is 230 over 7. Okay? Now similarly, we will do the same for the new product. So you could say alpha squared over beta multiplied by beta squared over alpha. Because we're multiplying, we can just merge them both together to get alpha squared beta squared by multiplying tops and multiplying the bottom. So that gives us alpha beta. However, we want this in terms of just alpha plus beta and alpha beta. So we can factorise the numerator to get alpha beta squared over alpha beta. And we know that alpha beta is minus 7 squared over minus 7, which gives us 49 over minus 7, which is minus 7. And that is our new product of the roots, alpha squared over beta and beta squared over alpha. So now, in order to make a quadratic equation out of this, we have to say that it's x squared minus the sum of the roots, and we know that the sum of the roots is 230 over 7x, plus the product, but because this number is negative, plus and a minus becomes a negative, so minus 7 equals 0. However, the question asks us for integer coefficients, and we have a fraction here, so in order to make every number integers, we have to times through the whole equation by 7. So 7 times x squared is 7x squared, minus the 230 would remain there, 230x, 7 times minus 7, minus 49, equals 0. And that is your final answer for a quadratic equation which has roots alpha squared over beta and beta squared over alpha. I hope this has helped, and just practice away, and join me for further tutorials if you need any further help.